The thrill and peril of hazardous materials, storage and transportation. Imagine a truck carrying highly flammable chemicals speeding down the highway. A single mistake, a tiny spark, could turn it into a catastrophic explosion. In another part of the world, a chemical storage facility is holding thousands of tons of toxic substances. One accident could contaminate the air and water for years. The world of hazardous materials storage and transportation is a high-stakes game, where precision, safety, and expertise are the only things standing between order and disaster. Today, let's dive into the fascinating and dangerous world of hazardous materials management. 1. What are hazardous materials? Hazardous materials, often called HAZMAT, are substances that pose a risk to human health, property, or the environment. They come in many forms. 1. Flammable and explosive materials, gasoline, propane, dynamite. 2. Toxic and poisonous chemicals, pesticides, industrial solvents, chlorine gas. 3. Radioactive substances, uranium, plutonium, medical isotopes. 4. Corrosive substances, acids, strong bases, battery fluids. 5. Biological hazards, infectious waste, viruses, bacteria. Governments and international organizations, such as the United Nations, UN, the Department of Transportation, DOT, and the International Maritime Organization, IMO, classify hazardous materials based on their properties and risks. 2. The high-stakes world of hazardous materials storage. Storing hazardous materials is not as simple as placing them in a warehouse. Each type requires strict safety measures to prevent leaks, explosions, or contamination. 1. Special storage facilities to prevent accidents. Hazardous substances must be stored in highly controlled environments. 1. Flammable liquids, e.g., gasoline, ethanol, stored in fire-resistant tanks equipped with ventilation systems. 2. Toxic chemicals, e.g., chlorine, ammonia, kept in secure, leak-proof containers within isolated areas. 3. Radioactive materials, stored in lead-lined vaults with extensive shielding. 4. Corrosive substances, e.g., sulfuric acid, sodium hydroxide, contained in reinforced, corrosion-resistant drums. These storage sites often have explosion-proof walls, emergency drainage systems, and temperature control mechanisms to prevent disasters. 2. The science of fire prevention. Fire and explosions are the biggest threats in hazardous material storage. To counteract this, advanced fire prevention systems are installed. 1. Automatic fire suppression systems that release foam or inert gas instead of water, which may react with chemicals. 2. Oxygen reduction technology that decreases the oxygen concentration in storage rooms to prevent combustion. 3. Advanced gas detectors that identify leaks before they reach dangerous levels. One famous example of failure was the Tianjin chemical explosion, 2015, China, where improperly stored ammonium nitrate caused a blast equivalent to 800 tons of TNT, killing over 170 people. 3. Human factor. Training and safety protocols. Even the best storage facility is useless without trained professionals. Workers must be trained to 1. Wear proper personal protective equipment, PPE, such as gas masks, flame-resistant suits, and chemical-resistant gloves. 2. Follow material safety datasheets, MSDS, which provide detailed handling instructions for each chemical. 3. Conduct regular inspections to detect early signs of leaks, corrosion, or structural weaknesses. In many countries, failure to follow these regulations results in huge fines, shutdowns, and even criminal charges for negligence. 3. The dangerous journey. Transporting hazardous material. Transporting hazardous materials is like carrying a ticking time bomb. It requires precision, regulation, and constant monitoring. 1. The routes of danger. Air, land, and sea. Hazardous materials are transported via trucks, trains, ships, and planes, each presenting unique risks. 1. Road transport, trucks, the most common method but also the riskiest. 1. Accidents. Poor road conditions and driver fatigue can lead to deadly spills or explosions. 2. Rail transport, trains, ideal for large quantities but poses a risk of derailment, as seen in the Ohio train chemical spill, 2023, USA, which led to widespread environmental damage. 3. Maritime transport, ships. Essential for global trade but vulnerable to leaks and spills, like the Deepwater Horizon oil spill, 2010, USA. 4. Air transport, cargo planes. The fastest but most restricted, as pressure changes can cause dangerous chemical reactions. Each mode requires specialized containers, strict documentation, and real-time monitoring to prevent accidents. 2. Emergency response to hazmat accidents. If an accident occurs, response teams must act immediately to contain the damage. Keycap 1. Identify the material. Using hazmat placards and UN numbers, response teams quickly determine the nature of the hazard. Keycap 2. Evacuate the area. If the material is toxic or flammable, people within a certain radius must be evacuated. Keycap 3. Deploy containment measures. For liquid spills, teams use absorbents. For gas leaks, neutralizing agents are released. Keycap 4. Monitor the environment. Air and water quality tests are conducted to assess long-term effects. The Chernobyl nuclear disaster, 1986, USSR, is a prime example of failed response strategies, where delayed action led to widespread radioactive contamination. 3. Packaging and labeling. The last line of defense to prevent accidents, hazardous materials are packaged in 1. UN-certified drums and tanks designed to withstand pressure and impact. 2. Specialized gas cylinders for compressed and flammable gases. 3. Shock-absorbing containers for radioactive materials. Each package is labeled with warning symbols, hazard codes, and safety instructions to ensure proper handling. In a world filled with dangerous chemicals and materials, storage and transportation are not just about logistics, they are about survival. One mistake can lead to an environmental disaster, a deadly explosion, or a toxic catastrophe. But through advanced technology, strict regulations, and human expertise, we can keep these hazards under control. The next time you see a tanker truck labeled with a hazardous symbol, remember, behind that simple container lies a world of science, safety, and precision. Stay aware, stay informed, and stay safe.